Hello friends, welcome to Awdhesh Academy, and today we are going to start the last lesson of the chapter sets of the class 11's maths. The title of the lesson is complement of a set. Now what is complement of a set? So we already know what is universal set and what is a set. This is how we have represented the set and the universal set in the Venn diagram. So when we are talking about the complement of a set, the complement of the set means that all the area which is outside this particular set in the universal set is called the complement of the set. That means from the universal set, if we subtract this particular set, what we get is complement of this set. And the complement of a set is represented as A dash, and it can be said to be X such that X is a member of U and X is not a member of A. So this is the proper definition of a complement of a set. We can also say that A dash is equal to U minus A, because what is present in U but not present in A will make a complement of the set. From here we can also see that this complement of a set A, that is A dash, is also a subset of U, because this is also contained within U. So here we can see that this universal set has two subsets, one is A, other is the complement of a set, which we can say A dash. So how to define a complement set? Complement set can be defined as following. If U is a universal set and A is a subset of U, then the complement of A is a set of all elements of U which are not the element of A. Now let us take one example. Let us say that U is a universal set whose elements are 1, 2, 3, 4 up to the number 10, and A is a subset of that and its members are 1, 3, 5, 7, 9, that is the odd numbers under 10. So if we have to find out A dash, then what we have to do is that we have to find out what are the elements which are there in U but they are not in A, and we can easily see that 2, 4, 6, 8 and 10 are there in U but not in A, and therefore this becomes the complement. Now let us take the second example to understand this concept of complement of a set. Let us presume that U is equal to 1, 2, 3, 4, 5 up to 6, A is equal to 2, 3, B is equal to 3, 4, 5. Now we have to find out A dash, B dash and A dash intersection B dash and A union B. So let us first find out, and we have to show that the complement of a set A union B is equal to A dash intersection B dash. So let us solve the problem and you will see how easily we can solve it. Now A dash, as we know, is equal to 1, 4, 5 and 6. That is, we remove the members of 2, 3 from this and we get A dash. Now what is B dash is equal to 1, 2 and 6. Now let us try to find out what is the value of A dash intersection B dash. Here we can see what are the common element. 1 is common and 6 is common. So this is the value of A dash intersection B dash. Now let us find out A union B. A union B will be equal to 2, 3, 4 and 5. Now if we take the A union B's complement, then we can see that 1 is not there and 6 is not there, and therefore we can see that these two values are same, and this is proven thing. So we have learned in the previous example that the complement of A union B is equal to A complement and intersection of B complement. In the same way, the intersection of A and B, if we take the complement of that, it will be equal to A dash union B dash. That means it will be equal to the union of its complements. So these two laws are called De Morgan's law, and they are extensively used in the set theory. Now let us understand the properties of the complements of sets. The first property is called complement law, and here there are two sub laws. First says that A union A dash is equal to U. It is very easy to understand because A represents the area inside this particular circle A, and A dash represents all the area which is outside A. So if we take union of the two, automatically what we get is union. The second law says A intersection A dash is equal to phi. This is also very easy to understand because A will represent the area inside this, A dash will represent the area outside it, and therefore if we take the intersection of the two, there will be no element within this. The second is De Morgan's law, which we have already learned and discussed in detail. The third is called the law of double complements. If we take complement of A, it becomes A dash, and this is the entire area. Now if we take the complement of A dash, then what is left is nothing but A, and therefore A dash double dash is equal to A. The fourth law is law of empty sets and universal set. This is also very easy to understand because phi dash is equal to U, because phi has no element at all, and therefore if we take complement of that, it will have all elements of U. In the same way, if we take the complement of U, which is already having all the elements, then it is going to be phi or a null set. Now let me explain the De Morgan's law by the help of a Venn diagram. The first law says A union B dash is equal to A dash intersection B dash. Now let's see what is A union B. When we are talking about A union B, A and B union is represented by this green shaded line. Now if we talk about the A union B's dash or the complement of this, then you exclude that area and the remaining area which is shown in red will be showing as A union B dash. Now we come to the next part or the right hand side. What is A dash? A dash means the area of the universal set other than A. So this is represented in this green shade. In the same way, B dash is represented by all the area outside the set B. Now if we take the intersection of that, we find that the intersection will be this. And therefore we can see that the intersection of these two sets are one and same, and hence we can prove this De Morgan's law, first theorem. Now let's go to the second theorem. It says that A intersection B dash is equal to A dash union B dash. Let's prove this. What is A intersection B? A intersection B is represented by this small area, which is the intersection of A and B. If we take the complement of that, other than this small area, the entire area will be covered under the complement. So excluding this small area, remaining area is A intersection B's complement. Now let's go to the right hand side. What is A dash? A dash is equal to the entire area which is outside A. Similarly, B dash is equal to the entire area outside B. And if we take the union of that, we find that other than this, because this area is neither in A dash nor in B dash, and other than this area, the entire area will be representing A dash union B dash, and these two areas are exactly same, and therefore we can say that this theorem is also proven. We'll now try to understand how to calculate the number of elements in the different sets of operation. Now this is a universal set. You have two sets here, A and B, and we are also seeing that there is an intersection here which is represented as A intersection B. So if you want to find out how many elements are there in A union B, that is this total area, then we add NA plus NB. But what we find here is that this area or the elements which are common between the two has been added twice, and therefore we have to subtract it once. So that is how the formula comes: NA union B is equal to NA plus NB minus NA intersection B, because this area has been added with this also, and therefore this is the formula. If we have a disjoint set, that means there is nothing common between A and B, then this will become null, and therefore NA union B will become NA plus NB. And if there are three sets A, B and C, then the formula will be NA plus NB plus NC minus n A intersection B, n B intersection C, and n C intersection A, and then finally we'll add n A B C's intersection. So this is how we can derive the formula for 3, and this is the formula for 2, and this is how we can find out the number of elements in different type of permutation combination of these sets. So thus we have learned in this particular lesson what is the complement of the set. We have learned about the De Morgan's theorem. We have also learned about the calculation of the number of elements if there are different operations of the set. So I hope that you have been able to understand the concepts clearly, and please solve problems which are there in your textbooks to get more clarity on the matter. Thank you very much for watching the video. Keep watching the video. We will be putting up the next chapter very soon. Thank you.